Okay, in this video we're going to look at the so-called area theorem. So this theory says if R is a region to which Green's theorem applies, and C is it's a positively oriented boundary, then the area of the region is given by this expression here. So if this is the region R, C is boundary positively oriented. You're going to recall we said it's positively oriented if as you traverse around C, the region is on your left. Then this expression here is going to give us the area of this region. So let's prove this. So according to Green's theorem, in this line integral, we have P is negative 1/2 y, because P is the coefficient of dx, Q is 1/2 x. So Py is negative 1/2, Qx is 1/2. So if we call this thing I, then according to Green's theorem, I is the double integral of Qx minus Py. So it's going to be negative 1/2 minus negative 1/2 dr. This gives us 1. So this is just this integral here, and we know, of course, this is just the area of the region R, okay, which is the area of the region R. So there's an interesting theorem which says that we can find the area of a region by simply integrating around its boundary here. In fact, this expression here is not unique. Any choices of P and Q such that so the main thing here is that Qx minus Py must be equal to 1. So long as that is satisfied, then that expression is going to give us the area of the region. So you can imagine Q is equal to X and P is 0 is going to work, or P is negative Y. Any of those are going to work. Right, so let's just do one example to demonstrate the use of this theorem here. Okay, so suppose we want to use the area theorem to find the area of the region bounded by the curve x squared plus y squared equals to a squared. So of course we know that this is going to be a circle centered at the origin, radius a. So we're going to use the circular theorem. So the area is going to be given by the integral of x dy minus y dx. So along this contour, we're going to parameterize. So x is going to be a cos theta, y is going to be a sine theta, and theta is going to vary from 0 to 2 pi. So we simply plug into this, so integral from 0 to 2 pi x is a cosine theta, dy is going to be a cosine theta d theta, and then take away y is a sine theta, dx is going to be negative a sine theta d theta. If we tidy things up, so a squared is going to come factor through. Then we're going to have cosine squared theta plus sine squared theta d theta, which of course we know is equal to 1. So this is simply 1/2 a squared integral of d theta from 0 to 2 pi. So this is going to be a squared on 2 times 2 pi. This is going to be pi a squared. Okay, so that demonstrates the the area theorem, which is based on Green's theorem in the plane.